Thank you, everyone. Happy to be here today. Good to see a lot of friends, industry partners, clients in the room, so thanks for making this possible. So, for those of you that work with me or know me, you may not know my full history, so I'll run through that quickly. I've spent my last 15 years in construction waterproofing specifically. In this time, I've worked on over 300 Class 2 developments and a range of other commercial and infrastructure projects. I'm currently the founder and principal consultant of Waterproofing Integrity, and we specialize in waterproofing design, inspection, and quantitative testing. And finally, I contribute to a number of committees for the progression of construction waterproofing. So, what are we going to be talking about today? So, I've had a look at the guest list. I know you are all very well educated people, so I'm going to dive into some pretty heavy content here. So bear with us as we make our way through. I've no doubt you'll have a few questions at the end. So first of all, we're going to cover basement design in accordance with the NCC. We're not going to talk too much about how to actually design a basement. We're going to talk about how I believe basements should be designed in order to comply with the requirements of the NCC, because that's something that I think no one really knows too much about at the moment. Second of all, we're going to cover NCC 22 changes in regards to waterproofing in a little bit more detail. Then we're going to move into waterproofing design development under the Design and Building Practitioners Act. And finally, we'll touch on inspection and testing of waterproofing systems. So, many basements have been designed and constructed in Australia, but how many of these have ever been verified or validated for compliance with Part F health and amenity requirements? Stan touched on before our pathways for satisfying our performance requirements under the NCC. To recap, we either have deemed to satisfy or it's a performance solution by default. Now, knowing that we don't have any deemed to satisfy provisions for basements in Australia, I think we can all agree that it's a performance solution. Every basement is a performance solution design. So I'd actually like to ask everyone a quick question. Who has ever seen or been involved in the development of a performance solution for Part F amenity of a basement? Any hands in the room? Okay, so this is something I admittedly don't understand how we've gotten this far in the industry without addressing this. Yet here we are. So what I'm going to present to you is what I see as a pathway for when this inevitably becomes asked for on every project. Okay, this is just a quick recap of Part F, which covers our performance requirements for surface water management, rising damp, and external waterproofing. Okay, now in the NCC 2022, in this presentation I'm going to be using all of the new clause numbering just because we've got to get used to it sooner or later, right? So in NCC 2022, it's Part A2G2, which covers our performance solution requirements, right? And in that section, we are given 4 assessment methods which allow us ways of validating our performance solution. First of all, evidence of suitability. Second, verification method. Expert judgment is third, and comparison with deemed to satisfy provisions. Often it will be a combination of these assessment methods to justify a performance solution, but we will come back to that. Okay, so to add on to what Stan brought up before, in the Amendment 1 of 2019, NCC, we actually had new requirements for performance solutions introduced, because it's true there were a lot of 2-page performance solutions going around. So the big change was the introduction of a performance-based design brief. And to put that simply, what it is outlining the approach that we're going to use, identifying, okay, this is our scenario, this is our project, this is our scenario, these are the performance requirements that we're trying to demonstrate compliance with, this is the analytical approach which we are going to apply. This is the supporting evidence we're going to develop in order to do that. The formatting, content, and final report, and quite importantly, the acceptance of stakeholders, which are our design experts. So, knowing that that's been introduced, we now need to say, okay, well, what are we going to cover in our design brief? What's our approach going to be? And to further this, I'm going to introduce you all that aren't already familiar with British Standards Guide BS 8102. Now, something I'd like to mention first is in Australia, when we talk about standards, it's a deemed to satisfy provision, right? It tells us how to do something in order to be compliant. This, while it's developed by British standards, it is not actually standard in the way that we're familiar with it. It is a code of practice. It provides guidelines on how we should undertake the process in order to achieve a required level of performance, and it's actually a great guide. So the above flowchart defines the BS 8102 design process, and we're going to talk to a few things that it covers right now. First of all is geotechnical considerations. Site-specific is always the starting point, most basic of which is, are we above or below the water table? Shown on the right is a diagrammatic example of different hydrostatic forces that may be expressed onto a below-ground structure and must be considered during the design process. Next, we have structure. On the left, we have a sheet pile shoring wall structure with a pre-applied waterproofing system, and then a reinforced concrete structure is built over the top of that. What we have on the right-hand side is effectively the opposite. We have a block wall structure that is built first, and then we have a post-applied waterproofing system. So it's important to note that the type of structure that we're intending to use can limit or restrict what type of waterproofing protection measures we can put in place. Which leads me into waterproofing protection measures. So BS 102 breaks down our waterproofing types into three, A, B, and C. Type A is an external barrier system, can be applied internally, but most often it's a continuous waterproofing system applied externally to the structure. Type B is structurally integral measures, often including a concrete additive to make the concrete waterproof, or water stops at construction joints or other similar elements. And then finally, C is probably the least commonly known in Australia. It is the drained cavity system, which allows water to enter through the structure, but is contained effectively while it's shed into the stormwater system so that it doesn't interact with any other elements of the building. And finally, BS 8102 provides a breakdown of different grades of waterproofing performance. So this is the actual extract here. We have 1A, 1B, 2, and 3, and I'll run through some indications of what they are. So 1A allows seepage and dampness from external or internal sources and is tolerable as long as it doesn't impact the proposed use of the basement. So here we have a wet wall basement, water coming in, whether it's from the ground or a rain event. It's coming down the wall, it's being captured at the bottom, it's not running out on the floor, it's not impacting amenity, so all's well. We move up to 1B, slightly better design, still has notable dampness on the wall, but doesn't actually have any running water into it. Grade 2, this is probably a bit of a harsh example of a grade 2, but this is mold growing. It's not actually water coming from the outside of the basement. This is slight moisture migration through the structure and a lack of ventilation inside the basement, which promotes moisture and dampness and mold growth. So that's a grade 2, can be acceptable for some sort of storage areas as well. And then finally we move into grade 3, which we've got a nice cinema room here. Obviously no seepage, no dampness, no high humidity in the air, habitable space. Okay, so now we've identified we have a pathway that we can follow to create a good basement design. We're going to bring this back to how we tie into the NCC. So I've got this same slide up here again, part A2G2 for performance solutions. And what I've highlighted here is points B and C as the assessment methods. The way I see it, and this is open to interpretation, is that when we conduct our design process in accordance with BS 8102, we are doing a hybrid combined approach of a verification method and expert judgment, because BS 8102 process does not work unless we engage all our relevant geotechnical, structural services, waterproofing specialists into the process. Everyone shares their perspectives and opinions to help that collectively come together. Then we move into the final stage. We've done our design, it's everything, everyone's happy with it, everyone's approved it. We need to prepare the final report. And essentially what this is, it captures all of our information and ties it together in a cohesive way that says, okay, we've established this process in our design brief, we've followed through, we've collected the information, and here's how we've developed a solution that complies with our nominated performance requirements. And I've highlighted this part here because this is taken from our guide developed by the ABCB. And it says, the development and approval of a performance solution can be made a relatively simple process if it's initiated and collaborative by the collaborative preparation of the performance-based design brief. So I just highlight that to reinforce that that's something that BS8 102 does very well in bringing the stakeholders together and getting everyone on the journey to develop that. So to finish up this section, this is why we go through this process. This is, and I'm sure everyone's seen a lot of other similar situations to this, where the basement just doesn't quite turn out the way that it should, and there's impacts to the amenity of that, the intended use of that area. Top left-hand side here, we have a wet wall basement that was having a significant amount of water coming through. So the builder on this project decided to put some blue board up on that wall, thinking that, okay, we've got a moisture-resistant product here, it'll contain the water and everything will be right. What actually ended up happening was that became saturated regardless and then promoted mold growth. So it may be a little bit difficult to see, but there's a significant amount of mold growth occurring on those areas, which can have a negative impact on the amenity of that area. Top right-hand side there, a pretty obvious one. We have a wall which was designed to be a wet wall, but it didn't have effective drainage and containment on the perimeter. So instead we have water running across the floor. Bottom left-hand corner, we have some nice electrical work and a pump here fixed directly to a wet wall, permanently wet wall from groundwater, which is not desirable for a number of reasons. And then bottom right-hand corner, we do have a perimeter drain here, but the drainage system wasn't actually efficient, if it was connected to anything, to actually handle that water that was coming in through that wall. So that's it for that part, and I'm going to move straight into part number 2, which is our NCC 2022 update. Stan introduced this already, but I'm going to go into a little bit more detail about what the actual changes are in regard to waterproofing. So great that they've now included our guidance levels of objective and functional statement. They were previously in the guide to the NCC. They've now been moved over into the NCC. It just helps with a little bit of clarity if there's ever any doubt about what the intentions are for those performance requirements, which are still our primary requirements. As Stan mentioned, we have now split it into 2 parts. We have F1, which is surface water management, rising dam, external waterproofing. That's pretty much everything to do with waterproofing on the building envelope, except for facade. F2 is internal wet areas waterproofing design, and F3 now gives facade and roof systems its own special category. The intention of this, as I've been told, is to provide increased clarity and divisions in those 3 areas, and it also allows future changes more easily, which are planned for some of these elements. Okay, so we're going to start off in part F1. Big part, we really only have 1 section. It's the introduction of exposed joints deemed to satisfy provisions. So this is actually a somewhat interesting one, is going to have a bit of impact on how we both design and build things. I'll just read through it quickly. Exposed joints in the drainage surface of a roof, balcony, podium, or similar horizontal surface must A, be protected in accordance with our waterproofing standard, nothing new there, but B, must not be located beneath or run through planer boxes, water features, or a similar part of the building. So that means now, before our landscape architects or architects go too far with their design, we need a committed structural design that identifies all structural joints. And what I mean by that is, it's very common for everyone to say, we don't have any movement joints. It's not just movement joints. Note number 1 here says that for the purpose of this, Exposed joint is a construction joint, control joint, expansion joint, contraction joint, movement joint, or pretty much any other type of joint. So that's definitely one to be aware of when this comes into effect. Next, we move into part F2 for internal wet areas, which we have a few more changes in here. First of all, we have a new verification method. Now, this verification method's actually quite simple. It allows you to demonstrate compliance with our first of two performance requirements for internal wet areas by having an overflow facility in your vessel. I didn't put a photo in here, but everyone's seen those small little holes in their vanity. If the plug gets blocked, water builds up, overflows into that overflow, right? To be compliant with this verification method, the outflow capacity of that overflow point must be greater than the inflow of the tap that's filling that vessel. Logically then, it should be impossible for that vessel to ever overflow onto the ground of the wet area. Now, this verification method, it satisfies F2P1, and F2P1 primarily is directed at having falls in our finished floor level so that any water that does overflow into those areas is directed to a drain point rather than running out the doorway. So this needs to be explored and discussed a little bit further, but potentially this gives us leeway to have flat floors in our areas outside our shower if we have these type of vessels in place. Just an idea for the moment, but something to be considered. Okay, next point. This slide is just to verify that we have in fact adopted the 2021 version of AS 3740. It doesn't say it up there, but it does actually reference it in the table at the end of the document. Now, this is replacing our previous table F1.7 in the NCC, which defines where we have waterproofing and water resistant systems in our internal wet areas. We now have a new section, and the one real significant change is that walls of a shower area must be waterproof. In the previous version, that was water resistant. So anyone who's done waterproofing, you'll know that it's common to come to site, you'll do 2 or 3 coats on the floor to get a nice thick 1mm, 1.5 millimeter waterproof membrane. When it comes to doing your shower walls, you'll do 1 coat, 2 coats. You'll get about 0.6 or 7 millimeters because that only needs to be a water resistant membrane. That's gone now, everything's waterproof. Okay. So this is an interesting a change that a lot of people would probably overlook, and I've actually got the difference here between the 2019 NCC and the 2022 NCC. And I think it's a bit of a wording change here, really, where the nuance is. So if you look at point B up the top there, it says that first of all, there must be a floor waste. Second, the floor must be graded to the waste to permit drainage of water. That's pretty simple, pretty open to interpretation. In 2022, it is got a little bit more clarity around that. So where a floor waste is installed, you must have a minimum continuous fall of a floor plane to the waste. Must be a minimum of 1 in 80 and a maximum of 1 in 50. I still haven't really figured out why they have a maximum of 1 in 50, possibly for accessibility. But what's really important is the minimum of 1 in 80 because that's our shedding of the water to the drains, right? The key words in there are continuous fall of a floor plane. So the question then is, what's a floor plane? Why is it ambiguous? Why don't we just say finished floor level or structural slab level? And my understanding of that is that then that allows the NCC to cover a range. It could be any floor plane, it could be anywhere in the build-up there. And that's why I've got the diagram on the side here. Bottom arrow is showing our structural slab with a fall to the drain where our waterproofing system is applied, and then we also have our finished floor level. And the reason that I believe that that's been left open is because it allows AS 3740 2021 to speak to it a little bit more without conflicting. So in 3740 2021, 2.31 we have now a requirement for falls in the substrate. And the substrate is defined as the surface to which the waterproofing membrane is applied. Most commonly, that will be your structural slab. So it's now clear that we need to have a 1 in 100 fall in those wet areas. Then there is also a requirement for the fall in the finished floor level. that varies depending on whether you're in a shower or outside the shower. So that's going to be a big change for everyone to accommodate as well. Then we move into our part F3, which all of our facade engineers are very interested in. The only significant change here is the introduction of deemed to satisfy provisions for wall cladding. We now have clearly stated three deemed to satisfy types. So we've got masonry, when it is built as per AS 3700. We have autoclaved aerated concrete, also known as Hebel, which is when it's built with the relevant standard, and we have metal cladding when it's constructed with that standard. So the intention there is that these are very well-known systems. It should make this easier during the development of our performance solution for the facade of the building. And that's everything for the changes in the NCC 22 for waterproofing. Okay. Now we're going to start talking about the Design and Building Practitioners Act, and more importantly, how to design waterproofing systems under this. So this is something we do on a daily basis. I'm going to just go back and do things high level here. We know we have our design declaration process. I'm going to make it really, really simplified here on what that means for the design and the construction. Step one, designers design a compliant building and lodge those documents. Step two, the builder builds in according to those documents and then submits their declaration that they have done that. To me, that's as simple. I know there's probably a lot of legal people that are cringing at my simplification, but it's as easy as that. That's the whole thing in a nutshell. So what's a regulated design? This is out of our Design Practitioner's Handbook, which is our best guide to what we should be doing. We have waterproofing listed in there as one of our 5 important things. So if it includes waterproofing, it needs a regulated design. This is something that's important to understand. We get this question daily. This is a list of all the roles and registration classes for designers. There is currently no registration classification for waterproofing. So then how does this fit into the whole picture? The intention is that because waterproofing is such an integrated part of either architectural or structural, that one of these practitioners will adopt it into their designs for which they are going to declare them. And then when they go to submit their design declaration form, this is an extract up on the screen here, there'll be points number 5 and also points number 6 if we have some performance solutions in it, where you as the design practitioner will declare that you have relied on expert advice. And that's where you'll reference whether it's a specialist of any type. In our case, waterproofing, you'll nominate us there, and then we are accountable for the advice that we've provided to the project. So that's how it works currently. This is one for all our remedial specialists. I know there's a good number of you in the team here. Design Building Practitioners Act applies equally to whether it's new construction or it's remedial. There are some exemptions, but there's not that many. I know there's a lot of work happening out there at the moment that's sort of being just squeezed into the, it's exempt sort of status. But the truth is there's a good chance that it's not. And this is out of our handbook here, and I think it's an important demonstration of that talks about waterproofing to a single unit. So it's exempt if you have work that is carried out as an alteration of the bathroom for a single dwelling. We have a note here that says if it's building work that spreads over multiple bathrooms, say we have a set of units and we forgot to put our floor drains in, our leak control flanges, and that needs to be rectified on all of the bathrooms. That now, because it spans over multiple areas, not a single dwelling, becomes a declared design. And that's our guidance from the handbook here. Okay, speaking of the handbook, what we've got up here is a heap of information. We're going to talk through that now. These are all the requirements related to waterproofing that are in the handbook currently. They're spread out throughout it, so it can be hard to find, but I've compiled it here. We have internal wet areas, we have some for below ground. We have another slide here that has our external waterproofing. So we know the handbook's told us you have to provide, this level of detail, and it's given guidance on, okay, these are the sections that we think are important. But the truth is, every unique junction. We know that we're not supposed to be building something unless we have a design for it. That means every unique junction has to have a design. Okay, so I'm going to give you a bit of insight on the way that we do this in order to achieve compliance with the requirements of the DBPA. Number one, waterproofing layout plans. Floor plans shows the extent of waterproofing. Number two, external section details. Number three, bathroom layout elevations. And number four, internal section details. I'm going to run through them quickly here, give you an example. There's a very small example of a waterproofing layout plan. You can see that it's broken down by type, extent marked. We've got a legend on the side there. Other things that it would otherwise include on a larger project: location of structural joints, life cycle movement range of structural joints, location of drains, overflows, full gradients in the areas requiring waterproofing, and reference markers for all section and plan details. Moving on to external section details. If it wasn't already obvious, we should have one of these for each floor of the building. External section details. So normally there will be 25 to 60 on a standard class 2 development of external waterproofing section details to cover the entire design. We've definitely seen more than that, up to 90, 100 plus, but those are very architecturally interesting projects. So I guess designers, that's something to keep in mind. If you want to build nice, interesting designs, then it's going to be difficult to document them, and that shouldn't be surprising to anyone. Okay, scale, it will vary. Might be a 1 to 20, might be a 1 to 10, might be a 1 to 5. That is dependent on the level of detail that's needed to be shown off in that section. We've got a few examples up here. We've got a hob balustrade suspended slab. We've got a planter box. I believe that was against a lift shaft. And then we've got another suspended slab here. Now, I don't have the time to say what should be included. You can see there's a lot of details and annotations in all of these. These details should show completely how to build this detail, including dimensions of angles. Any element that needs to be constructed needs to be clearly shown. You can't have anyone having a guess at what your design intention was on site, and it should also convey everything that's needed to demonstrate compliance for that waterproofing system. Bond breaker, junctions, penetration details, that sort of thing. Then we'll move into internal wet areas. So this is a bathroom layout and elevation. Everyone should be familiar with those. These are very useful for also showing our waterproofing extent. We can see in blue here we have our waterproof membrane to the floor areas, and then we have water-resistant membrane on the walls. We also have section markers, falls to drains, drain points, everything like that. You will want to have one of these waterproofing plans for each unique type of bathroom. I do not think it is necessary to have a waterproofing layout plan where there are slight dimensional changes, because often that will create over 50 on a project just to tweaking with the floor layout. But every unique one, maybe you have an ensuite with no bath, then you have a shower over bath in another, then you have a shower and bath in another one. So every unique one should have a waterproofing layout plan to show the extent. Ideal scale 1 to 20. Then finally, we move into section details for internal wet areas. So typically there will be 10. Most wet areas generally use the same details. So for any class 2 development, it will typically be about 10. And they will be either a 1 to 10, as we've shown on the left-hand side here for our vanity against the wall to show the extent and detailing there. We have a pipe penetration running through the wall. Or it might be a 1 to 5. In this case, that's a freestanding bath on the right-hand side there. Tip that for everyone that we always see, you won't put a leak control flange below your bath. It will have a hard pipe coming up through and connecting into the bottom of the bath. Every single time we see a freestanding bath that has a drain point below, when there's actually no intention of actually draining water there. Okay, so just to cap us off on this one, what's the purpose of all of this? I think we can hopefully have already started to see some benefits for those that are involved in constructing declared designs. The quality of documentation that's coming out is very thorough, and it means that you don't have to improvise or imagine anything on site, right? and that prevents big issues from occurring between trade interfacing, right? Say we have a very qualified wall builder coming to site. They're going to do their thing. The waterproofer, he's an expert, he's a veteran, but they don't know how their trades are going to come together, and that's how we potentially end up with very common issues like this. I think Stan even raised it in a similar manner, turning up onto the outside of the FC sheet. We have our sarking coming down on the left-hand side here, and then we have our waterproofing turn up the outside of our cladding or our brick veneer, creating a water entrapment zone. That is not good, but it happens a lot when there isn't a design for everyone to refer to and come together on. On the right-hand side here, we just have an example of what that should look like, or one potential option of what that should look like. We have our facade sarking interfacing with our waterproofing correctly. Nice continuous system, no possibility for entrapment of water, and then we have a flashing and damp proof course. And that pretty much takes us to the end of waterproofing design to satisfy the Design Building Practitioners Act. Okay, now we move into our very last section. So inspection of testing of waterproofing. It's what Waterproofing Integrity specializes in above all else. I'm going to start off with why you would want to do that. First of all is building declaration. All our builders out there, you know that you have an obligation to submit a declaration at the end of the construction that says that you've complied with the design, and you're going to want to have some supporting evidence for your own sake to demonstrate that you've achieved that. Next is certifiers requirements. Most certifiers now are upping what they require for their OC, and inspection and testing of waterproofing is a very heavy part of that. They need to see that evidence that it's been completed. Third is an obvious one, mitigating defects. Inspection and testing is effectively quality control. It's much easier to catch it during construction than to come back and fix it later. Fourth is warranty. This one is actually directed at our material suppliers. It's very common, and fairly so, that an issue happens, the material supplier is called out to site because they have a failed waterproofing system. They have a look at it and they say, well, this has been applied at 60% of the thickness. We're not going to warrant that anymore, nor should they have to. They've created a product that works effectively at 100% thickness. So making sure that it's right so that everyone is on the hook with their warranty requirements is great as well. Finally is deemed to satisfy provisions. Our newest revision of AS 3740 for internal wet areas has significantly more provision there for accepted testing methods, includes electronic leak detection, ultrasonic thickness testing, everything I'm about to talk about. The previous version of our external waterproofing standard is pretty light. It does have requirements for flood testing, thickness testing, but it's very vague about it. That's something that will be rectified in future revisions. Okay, design compliance. Not only should an inspection and testing include, is our membrane good, is it thick enough, does it have any holes in it? It's also, like I mentioned previously, going to be equally important to demonstrate a record that we have actually complied with the design. And I want to take a moment to just talk about something important on this. For the longest time now, myself being one of them, a waterproofer would generally come to site and they would do their work in accordance with the Australian standards and thereby complying with the NCC. Absolutely nothing wrong with that, until the Design Building Practitioners Act was brought into effect. Now there's something else we have to be aware of. Not only do we have to satisfy the standards, the design should already do that, but we have to comply with the design. And I would expect that you will often see that there will be certain elements of the design that exceed the Australian standards. That's your new bar. It won't work if you come to site and you ignore the design and you just work to the standards. It will be defected and you'll have to comply with the design. It's just how it works. So, for all of our contractors out there, get very familiar with having the designs with you, because they will vary from project to project. They should all be, as an absolute minimum, compliant with our standards and our NCC, but they will often exceed that, and you have to be aware of that. So it's made things a little bit difficult, but that's the nature of where we are at the moment. Okay, continuity testing. Continuity testing is a bit of a broad term, pretty much just identifies that a waterproofing system should be doing what it's doing, is intended to do, creating a continuous barrier to keep water outside and inside. Left-hand side here, we have Anthony at Waterproofing Integrity doing an electronic leak detection inside a pool. I believe this was Ganyama Park. Looking for any breaches using electronic methods. That pretty much involves passing electric current over the top of a non-conductive membrane. If there were any breaches in that membrane, that current will arc through that breach, create a circuit, set off an alarm, immediately identifying even the smallest of breaches in the system. Top right-hand side here, we have our good old-fashioned flood test. Still very viable, recommended to identify any issues. It just takes a little bit longer to get your outcome and can slow up the construction process. There are also a range of different electronic leak detection methods, but I'm not going to go too far into explaining that today. Next, we move into thickness testing. We've got 3 different ways of doing that here at the moment. Top left is the old-fashioned destructive test. Cut a piece out, measure the vernier calipers. That's great, can't beat it for accuracy. However, you are putting holes in a system that should not really have holes in it. So that's the drawback on that one. Bottom left here is our wet film thickness. For those of you that aren't familiar with it, the way it works is liquid membrane goes down, gauge goes in it, you lift it up, you see which notches have membrane on it, and that tells you what the wet film thickness is. You then do a bit of a calculation based on solid content, and it'll tell you what your dry film thickness is going to come out as when it's dry. Then you have the opportunity to rectify things during the process. I believe there is some wet film gauges available up in the corner there with Darren, so a very handy tool for spot checking during the installation. And then on the right-hand side here, we have an ultrasonic thickness gauge, which works by passing a pulse of sound through the membrane and measures the reverberation back from the substrate below the waterproofing system. All very handy to verify that our waterproofing system is installed as intended. Okay, adhesion testing. This is one that we do a little bit less commonly, but can be extremely important. It is worked by gluing a dolly down to the waterproofing system, doing a saw cut around that dolly to make sure it's disconnected from the rest of the waterproofing system, and then you use a device to apply pull force to it. It will detect how much pull force was being applied when the dolly actually breaks off the substrate. Why is this important? Liquid membranes, fully bonded liquid membranes especially, the performance of them is very tied to how well they are supported by their substrate. The photo we have here is actually a great one. It's an exposed car park deck. Obviously going to have a lot of force applied to that waterproofing system. Needed to be well bonded, because in the event that it became debonded, bubbled or delaminated from the substrate, it would be significantly weaker than the way it's intended to function when it's bonded to it. And you'd expect it to fail very shortly after that. So in the right circumstances, adhesion tests can be very important. The other thing which we use adhesion tests for is compatibility chain of products. Stan touched on this previously about checking that we have interfacing between different elements or chemistry of products, and there's so many products available in the industry, it's not always true that there will be test data between things. And sometimes it's good where we don't have that confidence to just do a spot check on this build up and make sure that we've actually achieved verification. It's not 100%, but it does provide a lot of confidence when you get a good result with this test. And that pretty much takes me to the end. I just want to say a quick thank you to everyone that's attended here today. You've made it all possible, and also our sponsors.